Hi girls. So we're taking a look at example 21. And example 21 is water of crystallization. Nobody ever likes this one. This one, well, yeah, this one I don't know why, but students always find this one difficult. I think because there's so much, it's so ratio based, and there's two different calculations that are very similar within it. So you've got the percentage of water of crystallization, and then you've got finding the x value. The percentage of water of crystallization, you can use mass, but for the x value you have to use moles because that's a comparison. Okay. Some of you came back to me and said that you were finding it confusing me using the two methods within the one question, which on reflection doesn't really make any sense either. So I'm sorry about that, girls. I guess I wasn't really thinking properly. So what I'll do is I'll use the old method for this particular question. I'm going to assign you two questions from the book. I'll do one of those questions the old method and one of those questions the new method, to facilitate the majority, because the majority of you are saying to me you're going to use the old method, and see if you can work backwards to figure out the 6 marker, which is fine. Okay, so taking a look at example 21, the first thing I want to say, girls, is I made a terrible mistake. The mean titer in this question should be is 15, but you titrated it against 25 centimetres cubed, so that needs to change to 25 in your question. Sorry about that. I knew there was one. I said it on the other video. I always know there's one that's wrong, but I can never remember to change it, which is my problem, I suppose. Okay, so this is our balanced chemical equation, and we're going to go the old method. So we need a volume, a molarity, and a number of moles. So our moles are 2 and 1. We're told that we used a 0.2 molar solution of HCl, and this is the question mark. We use 15 centimetres cubed of it, and we use 25 centimetres cubed, which would be normal because you use a pipette for the base. Okay, subbing that in, then it's 15 multiplied by 0.2 divided by 2 is equal to 25m divided by 1. And then to get your m, you're bringing your 25 across, so it's 15 multiplied by 0.2 over 2 multiplied by 25. And the answer to that comes out as 0.06 moles per litre. All right. You're then taking a look from here on in, as you have two choices. You can continue to work in per litre and round your other figures up. So you measured 4.2 grams out and put it into 250. You could multiply the 4.2 by 4, or you can divide this figure by 4 and work in 250. I've always felt that it's easier to do it that way, so that's the way I normally do it. So from here on in, you're comparing sodium carbonate and water, and you're trying to get to a percentage of water crystallization and an x value. Okay, so you knew you had 0.06 moles if you had a litre of this stuff. You didn't have a litre, you had 250. So you're going to divide it by 4 to figure this one out, and it's 0.015 moles. Okay. I want to convert this then to grams. So I want to get it in grams because I know I weighed 4.2 grams out. So I can figure out how much of what I did in the titration was the sodium carbonate. I know whatever's left over must have been the water. Okay. So 1 mole of that is 106 grams, and I had 0.015 moles of it. So therefore I had 1.62 grams of it was sodium carbonate. The total that I had weighed out was 4.2 grams. So the difference between those is the first piece of information that you get about the water, and that is that you had 2.58 grams of water as a result of that. So you know that the 1.62 grams was the sodium carbonate, and anything over 1.62 out of the 4.2 must have been water. You can use that value then to get yourself a percentage. So to get the percentage then, it's 2.58, and it's over the 4.2 and multiplied by 100 over 1, and that will tell you that you had 61.4%. Okay, 61.4%. That gets you your percentage, and that leaves you then with trying to work out your x value. So again, you're still comparing sodium carbonate And I think this is why students find it hard in H2O. But from here on in, you're trying to find a ratio. So you're comparing them as opposed to putting them together to make this 4.2. Because you are comparing now, you are going to have to ensure that you are going to work with grams, or not grams, with moles. 2.85 grams of this, and you had, what was it, 2.58 and 1.62. 1.62 grams of this. Okay, you're going to change both of them now into moles, so you're going to divide them by something different. This one's by 18 because 1 mole of water weighs 18. This one's by 106 because 1 mole of water weighs 106. So 0.015 moles, which we already had, but sometimes it's easier if you work it out a second time. And this one is 0.1433 moles. So this is our ratio, but it doesn't look like a normal ratio. So when you have a normal ratio, it's 6:1, 7:1, 10:1. So that's what we want to convert it to. So we look at these numbers. This one's the smallest one, so we divide across by the smallest one. And that's going to get you the 1 value. And the ratio then, when I type this one in, is 9.6. So to the nearest one, it's 10:1. And that means x is equal to 10. Okay. So you're going to try a couple, which is 13.15 and 13.16. Page number 192, and that's in your textbook. And you can do them both one method, or you can do both methods, whichever you prefer. I'll come on then and do a video for you of those two completed next week. Okay, and that leaves us then with, what are we looking for? Example 22. We've only got a couple more. 22, 23 and 24. 25. So we're nearly there. We'll have them finished early next week, and then we'll move on and take a look at where we're going next. Okay, thanks very much, and I'll talk to you soon.